start the lecture and then we can discuss it at the end again. Okay, so we have started the topic of travel demand forecasting. It has 4 stages. The first stage was trip generation. Okay, so we discussed trip generation as well as trip attraction in that. There was some numericals we covered. And then the next stage is trip distribution, which is to find out the destination of the trips, basically. So there are 2 methods by which we can do trip distribution. One is using the gravity model, which we covered last time. The other one is using the growth factor model. Okay, and today I will start with that, and then later on, inshallah, we will finish the other 2 remaining stages of the travel demand forecasting process. Okay, so in some cases for gravity model, you need origin destination metrics, and then for calculating the origins, the trip attractions and distributions, you need some previous data about the zone, the car household, the household size, and all these things. We covered it in the previous problem. So you need all that data, but sometimes the data is not available. Okay, so what we can do is we can use growth factor model. Okay, in growth factor model, we only have origin destination between different zones for present year, what we call as a base year. Okay, current or base year, the year from which you are starting your planning, and for the future year, the trip generation values for each zone for the future year. Okay, so for the current year, I already know how many trips are going from one zone to the other, and for future year, I just know total number of trips coming out of each zone. I don't know their destination. Okay, so then we can use the growth factor model to calculate the destination of trips in future, for future. So in growth factor model, the equation which is used is shown on the slide here. So we're basically calculating number of trips from zone I to J. Capital Tij refers to number of trips going from zone I to zone J. Okay, small ti means the present number of trips coming out of zone I. Gx is the growth factor for the same zone. So the trips are increasing by growth factor of G. Okay, for each zone. Okay, and then we have Ti, which is the number of trips between zone I and any other zone. Okay, Tix. Okay, and if you multiply Ti with Gi, it will give you capital Ti. Okay, which is a future number of trips generated from zone I. Okay, so and what else do we have? Small Tij, the present number of trips from zone I to zone J, and J is the growth factor for zone J. Okay, so now this Gi is the growth factor for the zone which is the origin of the trip, from where the trip is starting. Okay, and this G and this G are for the zones where the trip is supposed to go. Okay, the destination. Okay, so this one and this one is different. Okay, they may not be the same values. Okay, because they are for different zones. This equation is for a particular method of growth factor model, and that method is known as Fratard method. Okay, so this equation is basically the Fratard method, where you are calculating the future trips, capital Tij, using the present number of trips and the growth rate, and the present number of trips between 2 zones and the growth rate for each destination zone. Okay, so this equation is the Fratard method, and Fratard method is one of the methods for growth factor models. Okay, so Fratard method is one of the growth factor models which is applied for calculating the future destination of the trips. Okay, number of trips which will go to each destination in the future. Okay, so we have a study area which has 4 zones A, B, C, D. The origin destination for the current year is given. this one, the first table, and the number of trips, this is it. In the next 5 years, the growth factor is given. Okay, so you multiply 600 with the growth factor, you will get the trips for future. Okay, so this is how we are doing it. So growth factor is multiplied with the current number of trips, and you will get the future number of trips for that zone. For that zone. Okay. And this is it. Yeah, then we are. So let us apply. So have your calculators in your hand. Okay. Again, we need some calculations to be done, and I will do it in the same page where I was doing it earlier. Okay, so I will make basically we are making the origin destination matrix. So I'll put a matrix here, 5 by 5. Okay, origin is here, destination is here. This the origin, and then this is the destination. Make our life easier. We don't have anything in these cells. Okay, we call them the intrazonal trips. If you remember, it was one of the questions in the midterm exam as well. Okay, intrazonal trips, the trips between the trips in the same zone. Okay, so for example, I want to calculate the number of trips from going from B to A using the Frottard method. Okay, from B to A. So first of all, I need the future trips for B. The future trips for B is 770. 770. Okay, then I multiply with this ratio, the current trips. Okay, and the growth rate for the zone A, then the destination zone, as I said earlier. Okay, so the current trips between A and B is, or B to A is 400. Multiply by the growth rate of A, which is 1.1, by the summation. Okay, for all trips, for all the destinations, trips going from zone B to all the destinations. So I'm taking basically from the current trips from B to all zones, which is 400 and 300 basically. Okay, again, we don't have anything here as well. Okay, so let me check which this one, this one, this one, this one, there's nothing. And we also have, this is empty and this is empty as well. D to B and B to D. Okay, let me make this one empty as well so we don't make any mistake. Okay, so summation, then 400 to 1.1 plus 300, and the growth factor for C is 1.4. So 300 into 1.4. start from A, then this is the case. Okay, okay. Tell me the answer here.
Doctor, you don't have the answer because it's difficult to calculate. You're still in work.
Sorry?
You don't have the answer? The final
answer is in the book.
Because I'm still in the work. It's a little bit difficult to calculate. Okay, let me check.
393.9.
How much? 3?
393.95.
394. Okay, fine. Okay, then we do the same thing for this zone as well. So the future trips for B will remain the same, 770 into, now we need the current trips from B to C. The B to C current trips is 300 divided by the same summation. How much is it? Sorry, I need to multiply with the growth factor as well. For zone C, the growth factor is 1.4. How much is it?
$376.04.
3. Okay, then from I need from A to B, then I need the future trips for A. Future trips for A is 720. Multiply by the current trips for B to A. A to B, 400. Multiply by the growth rate of B, which is 1.1. Divide by the summation for all these. So 400 into 1.1. Then I have 100 into 1.4. And then I have 100 into 1.3. Okay, so for the remaining zone, only this will change. So this is for C, so C is 1.4 and 100.
$446.19.
Which one? This one?
Yeah, B.
Okay. If I go here, then it will be 100 into 1.3. See, the future trips are 980. The current trips 100. Then for D is 1.3. For A 100 and 1.2. To 1.2 plus 300 into 1.1 plus 300 into 1.3. Okay, and then when you come to D, the future address for D is 520. Current trips from D to A is 100. Growth rate for A is 1.2. Divide by the summation. So I have 100 into 1.2 plus 300 into C is 1.4. So 300 to 1.4 plus, that's it. Yeah. Okay, then in that case, it's 300 to 1.4. Okay, so each time I took the future trips, okay, and future trips are the current total trips multiplied by the growth rate. So these values, the first value which I have taken in each cell is basically the value from here. And how did we get this value? The present trip generation multiplied by the growth rate. So even if they did not give you this column, you can multiply these two and you can get the future trips. Okay. Then the current trip from the current OD matrix, which is already given for the same cell from A to C, then multiply with the growth rate of C. Okay, so like I said, this is different. When you are calculating this number, you are multiplying with the growth rate of A. And when you are putting in this ratio, then you are taking the growth rate of C. Okay, and then divided by, again, the current trips between for each row then. Okay, for each row. I'm taking the summation then for each row. Okay, so 400 into 1.1 was the number between A to B, and then 100 into 1.4 was the number between A to C, and then 100 into 1.3 was the number between A to D. Okay, so in the denominator, the summation is for the complete row. Okay, and each time you take the present number from the OD matrix and multiply with the growth rate of the columns. Okay, the column for which the number is taken. Okay, so and any other values you have calculated?
DA is 140.
Which one?
DA.
What do you mean?
First column, last row.
Last row. How much?
140.
140. One more thing you can do whenever you have to do such calculations, you can simply take it here from here and paste it in Excel. Okay, so if you're doing it on laptop, just take this complete equation, how it is written, you paste it in Excel, and with an equal to sign, it will give you the number. It will give you the answer directly. Any other number? Okay, so this is 16. And then I just change this one, 100, 300 into 1.4. 404. This is 116 basically, and this one is 300 into 404. Okay, so I've calculated some values and the equations are written for all of them. I believe they are correct. If you see any mistake, you can later on let me know. Okay, but this is okay. You can calculate the remaining values, or you can check it from the book. Okay. Okay, what did I miss here? Yeah, so after calculating the values, then we make them equal basically. Okay, so you calculate the value from A to B, and then you have a value from B to A as well. Okay, so in the end, then you take the average of these two values, and the number of trips from A to B or B to A will remain the average value. Okay, so if you look at the final table, the values are same. Okay, let me show how. Okay, this is why I calculated some of the values. Okay, so I make another table here. Again, 5 by 5. We have the same. Okay, so according to us, A to B is 446 and B to A is 394. Okay, so the actual number of trips, this is nothing. Okay, so this value and this value will be equal. How much? It will be 446 plus 394 divided by 2. And same value here as well. Okay, so whatever that value is, it will remain the same. Okay, similarly, what other value can I calculate? Yeah, this one. So C2, I calculated from A to C. Do I have from C to A as well? No, I don't have. I have B to C, and then I have C to, no, I don't have. Okay, let me, I have C to D, but I don't have, do I have D to C? This is 132. Okay. And this is done. This is okay. We take this one. $40. Okay. And then here I change the second number. 300. 1, 385. Okay, and then last one into 1.3. $455. Okay, okay. So to complete it, then A to C is 116 and C to A is 140. So 116 plus 140 divided by 2, and this will be the same for this cell as well. Okay, similarly, if you go here, then A to D is 132 plus D to A is 116 divided by 2. It will be the same value here as well. Okay, then we have B to C. B to C is 376. 376. Okay, and C to B is 385. Divided by 2. Okay, and the same value here as well. Okay, then the only one remaining is C to D. C to D is 455 plus D to C is 404 divided by 2, and same value here as well. Okay, now why did we do the last step? The last step is basically done because we wanted to make the trip attractions and productions equal. The number of trips coming from all the zones should be equal to number of trips going to all the zones. The total number of trips for the entire area should be equal, whether you are calculating number of trips coming or number of trips going. Okay, total number of trip produced and total number of trips ended should be same. Every trip which starts must end. Okay, so these two numbers should be equal. If you take the summation from row wise or column wise, you will get the same number. And this was done in the previous example as well, using the what they call the doubly constrained gravity model. Okay, so in the gravity model, we were doing it by applying double constraints. Here it is relatively easy because you just take the average and do it. In the gravity model, you have to do multiple iterations to make them equal. Okay, but anyways, if you have any questions, I can stop here and I can explain again. Is it clear? Okay, so the next step is that now you have the number of trips generated from each zone and the number of trips attracted to each zone, and you already have these numbers calculated from where you started. Okay, so 720, 770, 980, 520. The summation of the rows and columns in this matrix, if you take the summation of any row or any column in this matrix, it should be equal to these numbers, the future values which you already have, the present generation into the growth rate. You should be getting these numbers, but as you can see, when you take the summation, it is not equal to the estimated number which you had initially. This should not have been 693. this should have been 720. Okay, and so on and so forth. Okay, so in order to make these numbers equal, you can recalculate the growth rates. The growth rates will be actual upon estimated. So 720 upon 693, 770 upon 800, 980 upon 943, and 520 upon 554. So this will be the new growth rates. Okay, so if you want to calculate the new growth rates, now growth rate will not be for each combination of zone, they will be just for each zone. Okay, so for zone A, I'm calculating growth rate. So for zone A, it will be the future value which you have already estimated plus divided by the value which you have just calculated, 720 upon 693. So 720 divided by 693, 770 upon 800. And we have 980 divided by 943 and 520 divided by 554. Can you give me these numbers?
The number A 1.03.
1.03.
Second one 0.96.
Okay.
One 1.03.
Okay.
0.93.
Okay. Now, usually I said it earlier as well. If the difference for all the values is within plus minus 5%. Okay, so like the ideal is 1, right? 720 upon 720 will give you 1. So it is 3% above. Okay, and if you look at this one, it is 4% below. And if you look at this one, it's again 3% above. If you look at the last one, this is more problematic, which is 7% below. Okay, so if the difference is within plus minus 5%, like we said for gravity model, you can stop here. Okay, but you can see the for D, the difference is more than 5%. So at least one more iteration should be done. At least one more iteration should be done. So you will start from here. You start from this process again, but the values will be taken from this matrix and the growth rates will be taken from this table. Okay, so you will do this one, this step, and this one more time. Okay, but in the next iteration, in the new iteration, the numbers for origin destination should be taken from this table, and the growth rates should be taken from this table. Okay, so let me summarize what we did. We had current origin destination trips. We had future trips for each zone. Okay, using the growth factor. Okay, so what we did, we applied the Flattard method to calculate the future trips between each zone, between each pair of zones, and then we took the average to make sure the table is balanced. Total number of attraction is equal to total number of productions. Okay, and this is the final table which we got. You can calculate the values. The final. This table is given in the slide as well. So whatever values you have got, you will take the summation for each row, and this summation should be equal to the future number of trips for each zone. Okay, which they are showing here. So this is a summation of each row with the new values, and this is the future number of trips which we initially calculated. These numbers are not equal, so we will take their ratio to calculate the new growth rates, and then we'll do one more iteration with the new growth rates and these numbers now. Okay, so the previous table and the previous growth rates are gone. They will not be used now. In the new iteration, they will not be used. In the new iteration, you will use this and the new ratios which you have calculated, and I already explained the steps. And these iterations should continue until all ratios are within 0.95 to 1.05, meaning plus minus 5% difference. Okay. Obviously, it may happen that you do the new iteration and you get numbers, all numbers are exactly 1. It can happen. It can happen. Okay. But even if you don't get exactly 1, if you get between 0.95 to 1.05, still it is good enough. You can stop there. If all ratios are within 0.95 and 1.05, you can stop there. But keep in mind, with every iteration, the previous numbers are gone. Okay, with every new iteration, you will be using the ratios and the trips from the previous iteration. Okay, so you want to do second iteration, the trips will be used from here, from this table, and the growth rates from here. Okay, any questions? Okay, another method of doing the growth rate or applying the growth rate formula is the average growth factor model. We will not do any example on that, but procedure is very simple. Okay, you have the current trips between each two zones, and you have the growth rate for each zone, and that's it. You have the current number of trips, and then you have the growth rate for each zone. So the average growth factor formula says that the current number of trips, Tij, must be multiplied by the average growth rate of both the zones. So for example, if I come here, I'm just giving an example. So let's say I want to calculate the number of trips between A and B. The current number of trips between A and B is 400. Okay, this will be multiplied by the average growth rate of A and B. So the growth rate for A is I don't know, 1.1. Growth rate for B is 1.4, if I'm not mistaken. For A is 1.2, B is 1.1, sorry. So 1.2 and 1.1. Okay, this will give you the future value. Okay, so instead of doing this whole equation, now your work is very simple. Okay, so this is the simpler method. Okay, but obviously this one is more accurate. Okay, good things in life are more complicated. Okay, so this will give you the future number of trips between A and B. Okay, and you do the same thing for between A and C and A and D and all the other zones. Okay, so each time you are just taking the average of the origin zone and the destination zone, the growth rate of the origin zone and the destination zone, and you multiply with the current number of trips. Okay. And then you will get the future value. And again, the process will remain the same. After you calculate the future value, you take the average to make sure number of trips produced is equal to number of trips generated, and they should be equal. Then the summation of rows and summation of columns must be equal. Once they are equal, then you check it with the future number of trips, okay, for each zone. And if they are not equal, you recalculate the ratios and so on and so forth. Okay, so only this step is changing. Instead of applying this long equation for each number, you just apply this one. Okay, the remaining steps will be the same. Okay, once you fill up this matrix using this sort of an equation, then you will take the average to make sure number of trips between A to B and B to A are equal, and then you do the summation of each row and each column, and they should be equal to the total number of trips for future. If they are not equal, you will recalculate the ratios, and then you apply the new ratios on the new numbers and so on and so forth. Okay, and again it will continue till the growth factors are within an error of 5% from 1. Okay, so 5% from 1 means this. Okay. Okay, so like I said, only one step is changing. You want, you can try it on your own and you can show me the results. If you want to discuss, you have some problems, you can let me know. Okay, now we will move to the next step, which is the mode choice. Okay, now in mode choice, basically you are trying to find out the number of trips between two zones. Now what we have calculated in the previous step is the total number of trips between each two zones. How many trips from A to B, A to C, A to D, and so on and so forth. Total, this is total. But in mode choice, we are trying to find out of this total between each two zones, how many will take a car and how many go by public transport. Okay, now in the book they are saying they will refer to the modes as car and public transport, but you can fit in any types of choices you have. So if you have a choice, let's say car and taxi, okay, same thing, same procedure, only the choice is changing, right? The name is changing, but the procedure will remain the same. So in mode choice, basically you're trying to find out of the total numbers between a pair of zone, how many will go by car and how many go by public transport or any other choice. Okay, so the selection of mode depends upon a lot of factors. It may depend upon the income of the traveler. It may depend upon the availability of the transit service. For example, in Bahrain, you may not find a public transport service available at all locations. Okay, or auto ownership, how easy it is for owning to own a car and so on, and the relative advantages of each mode in terms of their cost, time, comfort, convenience, safety. Some modes are more safer than the others, some are cheaper than the others. Okay, so it depends upon all these things. So mode choice is a very complicated decision, or to find out mode choice is a very complicated process. So we will discuss here three types of mode choice models: direct generation of transit trips, use of trip end models, and trip interchange model split models. Okay, so these are three types of models which we will discuss. There are other types as well which are more advanced, but we will not discuss them here. Okay, so in direct generation models, we calculate the number of trips taken by the transit directly, okay, by either calculating the total person trips or total auto driver trips. The trips which are total number of trips from each zone or total number of car trips from each zone. Okay, so in this method, we assume that the attributes or the characteristics of the system, the public transport system, are not important for the decision of the travelers. Okay, travelers are not adopting car or public transport because of the features of the public transport. Okay, let me give an example. In Bahrain, okay, most of the people would like to have a car. Okay, people who don't have a car or who don't go by a car, it is not because the public transport system, they think that public transport system is better for them. No, simply because they cannot afford a car. Okay, if you increase their salaries, they will automatically shift to a car. Okay, there are some countries in which people who even have a car sometimes go by the public transport because they feel going to this area or at this particular time, the service provided by the public transport is better than my car. Okay, so the attributes of the system are important for them, and they're deciding on the basis of the attribute of the system whether they should go by a car or a public transport. Okay, but in many countries, it is not the case. People who cannot afford a car, they have to go by bus or public transport. Okay, so that even if you put like 200 people in one bus, those people don't have any other choice. Okay, and these people are known as I think I have used this terminology earlier as well. These people are known as captive riders. Who are captive riders? These are people who choose a mode because the other mode is not affordable to them. Okay, so irrespective of the condition of the mode, they have to select that choice. Okay, there is no other alternative for them. Okay, so like I said, in Pakistan fuel is very expensive. Okay, so people who cannot afford a car or a bike, they have to take a bus, irrespective of what type of bus you are giving to them. Okay, some people have to change the buses 2 or 3 times. They spend 1 hour 90 minutes in their trip. They will do it. They will accept all these things because affording a bike or a car is not possible for them. Okay, so these are known as captive riders, and this is the assumption which is made in the direct generation models that travelers are captive riders. That travelers are captive riders. Okay, so for example, if you have to find out the number of transit trips per day in a zone which has 5,000 people living on 50 acres, the auto ownership is 40%. Okay, 40% people have no cars and 60% have 1 car per household. Okay, and the number of trips per 1,000 people is given here. Okay, number of trips per 1,000 people is transit trips per 1,000 people is given here. Okay, so how many people per acre we have? So 50,000 divided by 50, how much you get? 100, right? Okay, 100. Let me come here. So people per acre, 5,000 divided by 50, which is 100. Okay, now if you come to the graph and look at 100. Okay, so the trips for one household, the trips for households which have one auto is around, let me use a line here. Okay, so let's say it's 220. Okay, so 220. Okay, there are 220 trips per household if the population density is this much. Okay, 220 trips per household, transit trips per household if the population density is this much. Okay, transit trips per day per 1,000 people. Okay, so 220 per day, 1,000 people. Okay, and then I add the trips for 0 household, again 100 people per acre. So I'm here in this point. Okay, numbers are an estimate. So this is, I think, 500. Okay, so 500. So 500 per day per 1,000. Okay, so if I can find out how many 1,000 people I have who have 0 car ownership, then I will multiply with this number. And how many 1,000 people have 1 car? 0 was 220, right? No. Okay. How many 1,000 people have 0 car ownership? So I will multiply with this number. And how many 1,000 people have 1 car ownership? I will multiply with this number. Okay. So in the question they said 40% have 0 car ownership. So out of 5,000, 40% have 0 car ownership, which is how much? How much is 40% of 5,000? It's 2000, right? Okay, and the remaining is 3000. Okay, so if you want to calculate the total number, then 40% was for 0 and it was 500. So 500 into 2, because this is per thousand. Okay, so not per person, it's per thousand. So 2000 will become 2. Okay, plus 220 multiplied by the remaining is 3000, so multiply by 3. Okay, so the total will be, total is how much? 500 into 2, 1000, plus 220 into 3 is how much? 1660. Okay, so these are the number of transit trips per day from this area. Okay, so the remaining will be, if you have the total number of trips, the remaining will be car trips. Okay, so for example, if this area has let's say 4000 trips, 1660 is by transit, public transport, and the remaining will be by car. Okay, so you can see in this calculation we did not consider the time, the fare of the public transport. We just said that each household, each number of 1000 people will have these many trips per day, depending upon the type of the area and depending upon the car ownership. Okay, so if they don't have car ownership, they will produce high number of transit trips, irrespective of the type of transit you are providing to them. Okay, then we have a trip ends model. A trip end models. In trip end models, we are estimating the mode choice before the trip distribution is estimated. Okay, so the number of transit trips also depend upon the land use and the socio-economic characteristics of the zone. Okay, so it is similar to calculating total number of trips. Okay, it is similar to calculating total number of trips. Okay, and again, quality of service is not incorporated. Even in trip end models, the quality of service is not incorporated. The time and the comfort and the convenience, even if it's a bad service, people will still go by that one because they don't consider the other choice. And the procedure for a trip end model has 5 steps. These are steps. First of all, calculate the total person trip productions and attractions by trip purpose, what we have done earlier in the last lecture. Compute the urban travel factor. We will talk about it later on. Find out the percentage of trips for transit using a mode choice curve. I will show it to you in the next slide. And apply auto occupancy factors and distribute transit and auto trips separately. Okay, so let us go through this procedure. Okay, the total number of productions in a zone is 10,000 trips per day. The number of households per auto is 1.8. Okay, these are average numbers. Okay, total number of productions, how to calculate it, we have already discussed that in the trip production stage. Okay, average number of households is they collected the data, how many cars in each household, and this is the average number. Residential density means number of people per area. Number of people per area. We have to find out the percentage of residents who can be expected to use the transit service. The percentage of the people who will use the transit service. Okay, so first of all, we have to find out the urban travel factor. The urban travel factor. Urban travel factor can be calculated using this equation. Okay, so equation is very simple. Average number of household per auto. Okay, household per auto multiplied by person density, residential density. Okay, household per auto is basically the inverse of this thing. Okay, so urban travel factor is basically residential density divided by households, auto density. Okay, sorry, I think I made a mistake here. This is already households per auto. This is already household per auto, but normally we calculate the inverse. Normally we calculate the inverse because we ask people how many cars you have, and then you calculate the total number of average number of cars per household. So normally we take the inverse from the people, the average number of cars per household, and then we do the inverse to get 1.8. Okay, so in any case, we need household per auto multiplied by the residential density divided by 1000. Okay, so for this area, the household per auto is 1.8. Multiplied by residential density, which is 15,000, divided by 1000. Okay, so which is basically 1.8 into 15. How much is it? 1.8 into 15. How much? You guys are sleeping? How much is this? $1.8 into 15. How much?
27.
27. Okay, so if you come to this graph, 27 is somewhere here. Okay, now this is the mode choice graph, basically. The mode choice curve, which they said, okay, using a mode choice curve. This is a mode choice curve. Okay, so you should have, data from many areas, and then you can plot this curve using the urban travel factor and the transit mode split. So you should have calculated the urban travel factors for, let's say, 100, 200 different zones, and for each zone you should know the transit mode split. Then you can plot this curve. Okay, but obviously this requires a lot of data. Then from here, the percentage transit strips is basically somewhere around, let's say, 55. So 55% of the residents of this area will use transit. Okay, so for example, out of 10,000 trips, out of 10,000 person trips, 55% will be using the transit, and the other will be using the car. Okay, and this is how you use it. Okay, then we have trip interchange models, in trip interchange models, basically we consider the characteristics of the mode as well. Okay, so if somebody is selecting car, then he is selecting car because it is cheaper, it is faster, and so on. Somebody is selecting bus, maybe it is more comfortable, and so on and so forth. So in this, if you are using trip interchange model, then the number of trips by each mode can change because of the characteristics of the system. In the previous two methods, it was not possible. Okay, so if you change the frequency of the bus, if you change the fare of the bus, and you're using the direct generation model or the trip end model, it will not give you any change in the number of trips by public transport and car. Okay, so if you feel people are getting influenced by the choice of the people is getting influenced by the characteristics of the public transport system, then you should be using trip interchange model. So in trip interchange model, basically we are saying any person can shift from car to bus or bus to car depending upon the characteristics of the system. Okay, and again, one of the methods for trip interchange model is called as QRS. QRS stands for Quick Response System. Quick Response System. The things you need to apply a trip interchange model is this: distance between different zones using auto and transit. Auto trips are usually direct and transit trips are usually indirect, so they will be longer. But the fare of the transit, out of pocket cost for the car users. Okay, transit fare is the only cost you have for the buses, but the car may have insurance and registration and so many things. Okay, so that's why we are saying out of pocket cost. Parking cost, if parking cost apply to any zone, then what are those? the speed of the highway and the transit service. Okay, highway will apply to car, transit will apply to buses or public transport. Exponent values B, I will come to it in a minute from this equation, but this is basically a constant which you need. The median income, middle income. Okay, median means exactly in the middle. Okay, so 50% people are earning more than that, 50% people are earning less than that. Okay, and excess time is the time which is part of your trip, but during that time you are not in the vehicle itself. Okay, excess time is that time of the trip when you are not in the vehicle, but still it is part of your trip. For example, walking to the bus stop, or waiting for the bus, or waiting for the train. You are not in the train or the bus yet, but this time is consumed in your trip. So this is what we call as excess time. Now, according to quick response system, the proportion of trips for any mode, let me make it better. So according to the quick response system, if you want to calculate the number of trips between zone I and J, let's say using transit. Okay, so transit is given with the subscript T, and A means auto. And as I said, you can replace them with anything. Okay, so it can be auto and bicycle. Okay, or bus and walking. Okay, any two choices. Okay, any two choices. So these are the two equations. This one is giving you proportion of trips which are using auto, and this is giving you proportion of trips which are using the transit service. Okay, and to calculate them, basically we need these I values. Okay, and this B subscript, the B superscript basically. Okay, so what is this I? Impedance of travel mode. Impedance meaning resistance. Cost, basically cost. Okay, so the cost which is offered by mode M. Okay, whatever mode you are considering, M can be basically here it will be A and T. A and T. So M, if you are considering, if you put for example here, I will be the impedance for auto, so M will be A, and here I will be impedance for here it is I for public transport, transit. Okay, so impedance for public transit. Okay, so the impedance can be calculated in this manner. They have already given an equation here. In vehicle travel time in minutes plus 2.5 excess travel time. I already explained what is excess travel time, into 2.5 plus 3 into trip cost per income per minute. Trip cost per income per minute. Okay, so this is how you calculate the impedance. Okay, so it depends upon the in-vehicle time. So a mode is faster, its impedance will be higher. Okay, oh sorry, if a mode is faster, the impedance will be lower. You will have less time here. Okay, similarly, if the excess time is higher, you have to wait more, then impedance will be higher. Similarly, if the cost is higher compared to your income and compared to the travel time, then impedance will be higher as well. Okay, so impedance is basically the resistance, the friction. Okay, you can say the things which you don't like about that mode. Impedance is a combination of things which you may not like about that mode. Okay, so these are basically three things: the cost of the trip, the time which you spent in the vehicle, and the time which you have to spend out of the vehicle, but still it is a part of the trip. So if the mode is cheaper, it takes less time, and there is no excess time, then it will have less impedance, and vice versa. Okay, so for example, if you apply this to Bahrain, if I have to walk to, let's say, 2 kilometers to reach to the bus stop, so the access time will be higher, so impedance for bus will become higher. Okay, if obviously the bus is slower, the car is faster, so this factor will be less as well in vehicle time. Okay, and the fare which I pay for the bus trip is, let's say, 500 fils, and I can take the same trip using a car, and the fuel will only cost me 200 fils. So again, the impedance for bus is higher in that case. Okay, so impedance is basically the resistance factor, okay, for each mode, the things which will take you away from the mode. Okay, so when this factor goes up, that means the impedance is getting higher. Okay, and B, like I said, is a constant, and they are saying it depends upon the trip purpose. Okay, so the value of B depends upon the trip purpose. Again, you have to collect some data and calculate the value of B yourself, but in the examples I will show you some standard values, the default values. Okay, so B depends upon the trip purpose. If you are taking the trip for work, then B will be different than if you are taking the trip for, let's say, shopping. Okay, so B depends upon what type of trip you are taking and whether you are going from home or whether you are going from somewhere else. Okay, so you can see there are two equations given for calculating the mode choice or the percentage of trips by auto. Okay, you can use this one or this one. You can use this one or this one. You don't have to use both. Okay, both will give you the same answer. Both will give you the same answer. Okay, and then once you calculate the percentage of trips taking auto, then you can calculate percentage of trips by public transport using this. And this is what? This is what? You have 100% trips. Out of 100%, let's say you calculate MS to be 60%. So the remaining 40% will be what? Transit trips. Okay, so this equation is not difficult. Okay, this is, even if I don't give you this equation, you know, if I have two choices, one choice is taking 70%, the other one will be 30%. Okay, so 12.7 is just like a formality. Okay, so to let's say we are assuming this data. Okay, we have data for auto and transit. Distance covered by auto 10 miles, distance by transit 8 miles. This may be because they have a rail service or something. Okay, so you can see the distance by transit is less. Okay, cost per mile. So they calculate the total cost of the entire trip for the car mode and the transit mode, and then they are dividing it per mile. Okay, and then we have access time of 5 minutes for auto and 8 minutes for transit. It may be because person has to park somewhere else and then he has to come back to his origin, to his house or to his destination. So the access time for auto may be from the parking area. Okay, for transit we know we have to go to the bus stop and we have to wait there, we know. Okay, there's a parking cost as well for auto. There's a parking cost as well. Obviously transit doesn't need any parking cost. The speed 30 miles per hour for auto and to 20 miles per hour for transit. Okay, which makes sense, transit is slower. The percentage of trips by auto and transit, exponent value, B value is given. Okay, B value is given 2, and all these values are between two zones. Between two zones. Okay, so all these numbers are for two specific zones. When you are going from S to D, then these are the values. Okay, median income is given $24,000 per year. Did I miss something here? Assume that the hour time worked per year is 120,000 per minute. Okay, so this will help us to calculate the impedance. Okay, so basically I need the impedance for auto and transit, and B value is 2. I know that. Okay, so let us calculate the impedance factor. Okay, so impedance is, let me write the equation, in vehicle time 2.5 into access time and 3 into trip cost per income earned per minute. So 3 to trip cost per income per minute. A minute of the trip time. Okay, so in vehicle time is given or not? No, it's not given. So I need to calculate the in vehicle time first of all. Okay, so in vehicle time for automobile. Okay, so I've given they're giving me the speed and the distance. Okay, so distance upon time is speed. Okay, so now I'm calculating the time, so it will be distance upon speed, right? So 10 divided by 30, and for transit it will be 8 divided by 20. How much is this? And then I need to convert into minutes. This will be in hours. So give me each value. Yes, anyone?
The first one, 0.0055.
Multiply by 60. Multiply by 60, okay? I think you divided it. 10 by 30 into 60. 10 by 30 and then into 60.
Yeah. 1 second.
Yeah, I send an email, okay?
Yes, I know.
It's a 20.
I send you, because I checked
Okay.
with him and our e-correction, whatever I've done.
What about this one?
Okay. Yeah, okay. So it should. Yeah, correct reference. I checked with the letter. So it will be
Can I see the slide again?
You can type it, Safa. You can unmute yourself. Okay, so this one is 24 minutes. Okay, Safa, you can unmute yourself. I had to unmute everybody. I was hearing some voices. Okay, anybody who wants to give an answer can unmute themselves. No problem. Or you can type it. Okay, so in vehicle time is calculated. Now access time is given directly. I don't need to calculate it. Now I need trip cost per income per minute. Trip cost per income per minute. Okay, so if I calculate the trip cost for car, then I have 0.15 per mile. So 0.15 into 10 plus 1. Plus 1.5 or 0.75 per trip. Okay, 0.75 per trip. So 0.15 into 10, the distance, plus 0.75 per trip. This will be the total cost. So I'm calculating the cost now. So total cost is for car. So 0.15 into 10 plus 0.75. Okay, this is for car, and then for transit, it will be 0.1 into 8, sorry, and then nothing. Okay, so how much is this? Okay, give me these numbers now. How much is this? 0.15 into 10 is 1.5 plus 0.75.
2.25.
This one 0.1 into 8 is 0.8, right? 0.8. Okay, so this is, yeah. So I need now, what did I need? I needed per income per minute. Okay, so 3 times, total cost 2.25 divide by income is 1000 or just income. Trip cost dollars per income earned per minute. So okay, so the median income will be taken here. Median income is given as 24,000 income per minute. So 24,000 is the income, median income, and the number of minutes worked in the complete year is 120,000. How did you get it? Usually 40 hours per week. 120,000 minute is calculated using 40 hours per week. Okay, so 5 days a week, each day 8 hours of working time, and then you multiply with the number of weeks, which is 52. So you will get 120,000 for the entire year. So 24,000 divided by 120,000. Okay, so this whole thing is in the denominator. 24,000 upon 120,000 in the denominator. How much is this? $2.25 divided by this whole thing, the ratio.
11.25.
11.25, and then you do the same thing for transit as well. This is for automobile. So only this will change. This will be 0.8. So how much is this now?
Four.
Okay, then I value for automobile is the in-vehicle time 20 plus excess time given as, where is it, 5 minutes plus 3 into the cost which you have calculated, 11.25. Okay, and I value for transit will be 24 plus 2.5 into 8, 3 into 4.
$66.25 IA.
Okay, and this one?
$56.
56. Okay, now the only thing remaining is to calculate MSA, the proportion of trips by each mode. So I go here. What's the equation here? As I said, you can use this one or this one. I will use the one which has a positive power. Okay, so I for auto 66.25 to the power B, which is basically 2, so square, we just bring a square, and then we have both of them again, summation. So we have 66.25 square plus 56 square, and that's it. How much is it? Yes, anyone? How much is this? This is 58%. So 58% people will take almost 58.32% will take the auto mode, automobile, and the remaining will be, how much is the remaining? (41.67%). So okay, so this is how you calculate using the impedance. You can say the impedance model, or they are saying the what name did they give? Yeah, quick response model. This is the QRS method of calculating the mode choice. Okay, and this comes under the trip interchange model, where we are considering the characteristics of the system as well. So up till now we have discussed 3 methods of mode choice. Okay, before that we completed 1 method of trip distribution. So the 3 methods of mode choice were direct trip generation, and what was the method? Yeah, trip and method or trip and model. In both of them we did not consider the characteristics of the system. Then we have the trip interchange model. Within trip interchange model we have just discussed 1 method, which is a QRS method, and it depends upon the impedance of each mode. Impedance basically means the resistance or the friction which is provided by each mode. Okay, the factors which you don't like about each mode, it depends upon that. So let us have a break. After 15 minutes break, we will look at the other method, which is again under the trip interchange model. Okay, which is the logit model, and this is what I asked you to prepare in your term project as well. So we'll discuss logit model after the break, inshallah. We will have a 15 minutes break now. So see you after 15 minutes break, and please have some coffee. Okay, I feel you guys are sleepy.